All right, geometry. So this is the 3D figures geometry toolkit video. This is the one we're going to fill out that yellow video and talk about what those formulas are and actually use them in a particular situation for a particular shape. So behind me you can see that video. What I'm going to do from my desk is walk through, talk a little louder from all the way over there at my desk, and talk through what the formulas are, what the definitions are. I'm going to do this entire thing front and back. Before I get too far along, if you don't have this either printed from that file that I shared, where you could go in and see all the toolkits, if you don't have this printed, you can come to school. I've got one printed. I've got a stack of 25 of them outside of my classroom door. You can come in whenever, pick up a copy for yourself, and look on the seat behind the desk. I have extra blank copies of all the other toolkits there too. Eventually, I'm going to scan all the geometry toolkits and upload those so that you all can make sure you've got a full set of complete correct toolkits. So that's the goal here. And in the midst of this, I'm also going to demonstrate why some of the formulas are what they are. It's kind of surprising and cool at the same time. So without any further ado, get out your toolkit sheet and let's take some notes here. Again, you could do this on your own, from your own printer. It doesn't have to be yellow paper, but hey, there it is. So, Aki, that's my name. Polyhedra, it's a 3D solid made up of flat polygon faces. A net is an unfolded box laid flat. For example, in one of my previous videos, I shared with you that if you just took a box and cut it open and laid it flat, that would be what a net is. And in a minute, I'm going to draw a pyramid, and you're going to get a sense of like what all the parts of that pyramid are and all of that. But a net is just if you could unfold the polyhedron or the prism or the pyramid or the cylinder or what have you. So I'm going to draw a couple of pyramids here. First of all, I'm going to draw a square-based pyramid. You draw a parallelogram, and then above there, you draw a point, and then dotted dashed lines for the things that are behind, and solid lines for the things that are in front, edges that you can actually see. Under here, that's your base. In this case, it's a square. Out here, this is an edge. If I were to shade this thing that I'm shading, that is a lateral face. This point right up here is called the vertex of the pyramid. But from a prior video, we know that this down here, this little corner, this one, the one in the back, those are all vertices too. But I just wanted to point that out, that that is a vertex when you have a pyramid, or if you have a cone. The point at the top is called the vertex, because that way you know, like if they say, oh, draw a pyramid vertex down, you would be drawing something like this. That's a quick way of pointing out to people how the figure is oriented. If it's right side up, upside down, or something else. The slant height, this term right here, it's going to be important to us when we get to formulas later. But if you go to the midpoint of this face and you go straight up to the vertex, that right there, that would be the height of the lateral face. It is the height of the lateral face. Slant height. Okay? Now, the reason why that matters is because when I want to get the surface area of this figure, I need to think about the area of that triangle. If I could just pull that triangle off by itself, I would need the height of that triangle and the length of this base here. Notice I capitalized this base because I'm talking about this thing down here, this rectangle or square on the bottom. But if I wanted the surface area of this pyramid, I would need the square base, and I would need the 4 triangles, the front, right, left, and back triangle. And I'm going to assume all these triangles are the same, that this is one of like an Egyptian pyramid where this vertex is perfectly above the middle of the base. The slant height would just be the height of this triangular lateral face, just the face of that pyramid. All right. Now, in the prior video, I used textbooks to talk about this thing called Cavaliere's principle. An oblique figure, like if I were to draw the same pyramid, now whether or not you want to draw this is up to you, but what I'm going to do is I'm going to draw it about the same height, but I'm going to tip it over. I'm going to put the vertex like way away from the base. And now I'm going to connect the vertex of this pyramid to all the vertices of the base. We'll finish off the base, and then there's this back edge. This is what's called an oblique figure. In this case, it's an oblique pyramid. Put simply, it's tipped over. It's just a figure that would look normal if someone hadn't like pushed it over. The height, still the same. The base is still the same dimensions. The slant height, that's not going to be the same. The edge length, that's not going to be the same. But if the height of this is the same as the height of the original one, and if the base edges all have the same length, then the volume would be the same. Tipping this over doesn't mean anything. Volumes are the same. Regular figure, an oblique figure, the volumes are the same. They both have bases, they both have all kinds of fun things that, similar language, but it's just that in this case the vertex is tipped over. Now we're going to come back in the future to this Euler's formula for polyhedra. It's an interesting formula for every polyhedron, and that's just a fancy word for pyramids and prisms and that kind of thing, tetrahedrons, all that stuff. It's a funny word for that, but it connects the number of edges, the number of faces, and the number of vertices. It holds for every polyhedron. It doesn't hold for cones and cylinders, but those aren't polyhedrons. Okay, so I think I've covered this. We're going to skip this table in the middle for now. So go down here. I'm going to zoom in a little bit so you can see with more clarity what's going on. A prism is a polyhedron with two congruent and parallel faces. A polyhedron with two congruent and parallel faces. If you look at this prism, the base is not the rectangle. Most students would go, oh, it's sitting on the rectangle, that's the base. No, actually, this triangle is the base, and the reason I know is because there's a congruent triangle back here. It's exactly the same dimensions, it's congruent, and it's parallel. If I were to pick this thing up by the bases, those two triangles would be congruent and parallel. So now, my formula for surface area and my formula for volume, it goes like this. Surface area is 2 times the area of the base plus the perimeter of the base times the height of the prism. So I'm going to put those little definitions down here. Big B represents the area of the base. P is the perimeter of the base. And H is the height of the prism. Just so you understand these formulas and how we're using them. Volume is area of the base times the height. Notice it's a capital B. Capital B means area of the base. It's a big deal, because if you use small case b, you're going to get confused. A lot of the figures where we try to find their area use a small case b, like base times height of a parallelogram. Well, that's nice and all, but this big B represents the area, in this case, of the triangle. So we're going to use these two formulas on this prism, and we're going to get its surface area and volume. So, by the way, it's really nice of them to give us a height like this. So that means the height of the triangular base is 6. And the reason why it's nice is because one of our formulas for getting the area of a triangle is 1/2 base times height. Base meaning the base of the triangle, so times 4, times 6 is your height. Plus, now I've got to get perimeter. I'm going to assume that this triangle is an isosceles triangle where this length is also 7 centimeters. I'm just going to assume that that's true and that's okay, and because otherwise I couldn't go on with this problem. So we're just going to work with it that way. So the perimeter of the base is going to be 7 and 7, 14, plus 4 is 18. Height of the prism is 12. Now I'm going to do a little mental math and clean this up a little bit. Sorry about that. I'm going to clean this up. The 2.5, that can go away. And so I get 24 plus 18 times 12 is 216. And when I add those two bad boys up, I get 240. And because we're talking centimeters and we're talking area, this is area. Area always has squared units. Area always has squared units. Always put units on your answer. By the way, this problem has the graphing standard, it has the symbolic standard, it has the numeric standard, and it has the communication standard. These problems hit all the standards at least once each. So please make sure that you are showing all your work and you're working with the diagram like I did. Sometimes I have to add something to the diagram like I did here. Showing all your work here too, okay? All right, volume. Well, here's the good news. Area of the base, I did that right here. 1/2 times 4 times 6. So I can clean this up. 4 times 6 is 24. Half of that is 12. So the area of the base is 12. The height of this prism is also 12. And you may remember that 12 times 12 is 144. Volume is always in cubic units. So the amount of air in our classroom is the amount of cubic feet. The amount of area inside this prism is the number of cubic centimeters. So that's prisms. So any shape that looks like this, where you have two congruent figures that are parallel to one another, that's a prism. Turn this sheet over. We're going to fill out the back side. We're going to keep trucking. Now, cylinder. Turns out the surface area is a nice little formula, and it is 2 pi r squared plus 2 pi r h. What this means is this is two areas of a circle. The area of a circle is pi r squared. So the area of a circle is pi r squared. So I'm getting two areas of circles. Well, sure enough, there's this circle on the top and this circle on the bottom. That makes sense. Circumference of a circle is either 2 pi r or it's pi times diameter. Well, they gave us a radius, so that's what I'm going to use. But 2 pi r, they're saying 2 pi r, well, that's like the distance around this edge. If I were to have a bug walk along this edge, that would be 2 pi r. That's like the perimeter of the base times the height. So this formula is actually super similar, super close to the area of the base, I'm sorry, two areas of your base plus the perimeter times the height. From the other side of the sheet with prisms, I've got two circles, and I've got the perimeter of the base, which is circumference, times height. So this formula doesn't come out of the thin air. It actually makes sense. So at this point, all I need to do for our particular cylinder is I just need to plug in the radius, and I just need to plug in the height, and then I'm good to go. I can figure this out. I'm going to show you your answer in terms of pi, and I'm going to show you your answer as a decimal. So 4 squared is 16, times 2 is 32, plus 2 times 4 is 8, and 8 times 15 is 120. So 32 pi plus 120 pi is 152 pi. We're talking area. It's square centimeters. Square centimeters. Now what is that as a decimal? Well, as a decimal, that's about 477.52 square centimeters. Now, you may be asked in the book or in an assessment to give your answer in terms of pi. That's what they mean. Like, you don't multiply this out to get the decimal. Don't pull out the calculator. Don't go to Desmos right away. Just leave the pi on the end, or if they want you to give the decimal, you'll know to give the decimal. I accept either answer, but if the problem asks for the answer in terms of pi, I'm looking for this guy. Volume. Volume for a cylinder is pi r squared h. And just like before, when we got the volume of a prism, it was the area of the base times the height. Well, the area of the base is a circle. So the area of a circle is pi r squared. We have that here. And the height, okay, that makes sense. This all goes together. Again, this formula doesn't come out of the thin blue air. It makes sense. So I'm going to use it on an R cylinder. It is pi times 4 squared times 15. I've got 16 times 15. And that comes out to 240 pi. Again, if I leave my answer in terms of pi, volume is cubic units. If I don't want my answer in terms of pi, I can give the decimal, and that is 753.98 cubic centimeters. There's our two answers for the cylinder. All right, moving on. We got to go to the pyramid. And I want to give you these two formulas. Actually, I want to give you the formula for surface area. We're going to work that out. And then we're going to come back and we're going to do volume and talk about why the volume formula is what it is. So surface area for a pyramid is area of the base, remember capital B means area of the base, plus 1/2 perimeter times slant height. This is something I neglected to mention before, so I'm going to ask that you flip your sheet over. We're going to add that to the front side. Slant height, they use the letter L, small case L. This is me trying to do a script L. So slant height, I'm just trying to do a script L like that. That's all I'm trying to do. They don't use the letter S because it looks like a 5, and S is also used for other things in mathematics, so they use the letter L for slant height. So, with that done, we have our formula, and so we may have a few things we have to figure out. For example, the area of our base. Well, so I'm going to work that out over here. My area of my base is, oh, by the way, I'm going to ask that you change that 2 to a 3. Just change that to a 3. It makes our math a lot easier. So, the area of my base is just 3 times 3. 3 squared, it is 9. So far I'm good. It's just 9. 1/2 the perimeter. Well, my perimeter is 3, and then 3, and then 3, and then 3. Remember, it's the perimeter of the base. So I've got 4 3s. So perimeter is 12. So I'm going to put that in here. And now we have to get slant height. That is going to take a little bit of work. And the reason is that I have the height of the pyramid, which is going to be useful when I get the volume, but I don't have this distance from the midpoint of this on up to the point at the top to the vertex. I don't have this. I got to work that out. Here's what I know though. If I connect to the center of the base and I go to the top with the height is 6, I just created a right triangle. So here's what I did. I'm going to draw it over here so you can see it a little clearer. Slant height is this right here. This is my slant height. Right here. And so the slant height is here. The height of the pyramid is 6. The height is 6. Now, what I did is I went down to the center of this base and I went over to the edge, and that must be half of what the whole side is. So the whole side is 3, half of that is 1.5. And you can see where I'm heading with this. I have to do a quick Pythagorean theorem problem to figure out what the slant height is. So I'm going to do that above. I know that 6 squared plus 1.5 squared is equal to my slant height squared. That's what I know. So I'm going to pull out ye olde calculator and work that out. 6 squared is 36 plus 1.5 squared. That's a grand total of 38.25. So the slant height squared is 38.25. So I have to get the square root of that answer, and I get that the slant height is 6.184. I'm going to leave that decimal on my calculator. I'm not going to do what a lot of kids do and just sit here and nervously tap on the clear button. I'm not going to do that. I'm going to leave that on my calculator. But I know what my slant height is, and that's good news. So I'm going to go ahead and I'm going to put that into my formula for slant height. 6.184. Like so. I'm going to multiply all that out on my calculator. Actually, I'm going to do half of 12 is 6, just to make the typing a little faster, a little easier. So here I go. And I'm going to work from right to left because the last answer I have in my calculator is this decimal here. So in other words, I'm going to go times 6, times 6 plus 9. And my surface area, after all that effort, is 46.108. 46.108, and they don't give us units, so square units. Done and done. All right. Volume. The volume of a pyramid, honest to goodness, friends, is 1/3 area of the base times the height. I'm going to pause on this for a hot second because I hope that rings a bell. I said earlier in this video that the volume of a prism is the area of the base times the height, and now I'm telling you that the volume of a pyramid is 1/3 the area of the base times the height. Let me point out to you why that is true. If I take a pyramid and I take the prism that goes with it, and what I mean by goes with it is this: it has the same exact height. The bases have the same exact area, and if I stack one on top of the other, they fit perfectly, okay? What I'm going to do is I'm going to take these green little tops off of here, and I'm going to do a little experiment. Because the question I have is it really that this is 1/3 of this? If this is 1/3 of this, I should be able to pour 3 things of rice into here with this. So here's one of them. I'll get a second one. Just so you know, I still have that one in here. Well, the mice need something to eat. And then I'm going to get the third one. And if you look, I'm going to pour it real nice. It really is 1/3. Honest to goodness, it really is 1/3. Now, I did lose a couple, but if you think about it, it really is 1/3. Now, water works a little nicer than this, but at the same time, I think you get it. 3 of these go into one of these, so the volume of the pyramid must be 1/3 the volume of its prism that kind of matches it. More on that in a minute. But let's finish this problem. One-third area of the base times the height. So here I go. 1/3, the base is 3 by 3, that's 9, and the height of the pyramid is 6. 1/3 of 9 is 3. 3 times 6, 18, and we're talking volume, so that is units cubed. The volume is 18 cubic units. Okay. Cone. Well, with a cone, its surface area is going to kind of be similar to that for a pyramid. It's going to have that slant height thing. Both cones and pyramids have slant heights. And the surface area of a cone is the base. So it's this circle, pi r squared, plus pi r L for slant height. That's your surface area formula for a cone. So here I go. Pi, my radius is 4 millimeters, got to square that. Use the radius again, it's 4. And the slant height, I don't know. So again, I got a little Pythagorean theorem problem, just like I did up here. So I'm going to do that in the space where the figure is. And I know that I got to do 4 squared plus 9 squared. That will give me my slant height squared. So that means I've got 16 plus 36. And 16 plus 36 gives me a grand total of 52. That is your slant height squared. I have to take the square root of that bad boy. And I get 7.211. But just like I did before, I am not going to clear that number out of my calculator. Or in your case, out of Desmos. I'm going to leave that in there. So that's the number I need over here now. I need to have that 7.211 number over here. And like I did before, I'm going to work from right to left. So like I know this is 16 pi, but I don't know how many pi this is. So I've got to go that number times 4, and that gives me 28.84 pi, which is about, when I add that 16 to it, that gives me a grand total of 44.84 pi, and the units, millimeters. We're talking surface area, so it is square millimeters. Not a unit we use a lot. Now if I want to get the decimal for that, I can just slap a pi on there, and I get 140.88 square millimeters, approximately. Again, my answer in terms of pi, and then my answer as an approximation. Either way, I've got square millimeters as my units on the end. All right, time for volume. The volume of a cone is 1/3 pi r squared h. I hope that rings a bell. First of all, to this whole thing with the pyramid, but second of all, to the cylinder. The volume of a cylinder is pi r squared h. The volume of a cone is 1/3 of that, 1/3 pi r squared h. So yes, I'm going to do that demonstration again real quick. Will three cones fit into one cylinder? They're the same height. They've got the same base area. Will they fit? Okay. Cylinder. Cone. When you guys come back to school, you'll be having some of this rice. It may or may not be the rice that fell on the floor. Here comes the second one. I'm getting most of it. Most of it. Not all. You know, but I'm getting most of it. And here we go. Nice and easy now. Easy. I'm going to tap it so it all falls in. And sure as snot on a hole handle, 3 of these fit into one of those. Now, there's probably a little bit of difference. Like I probably should have gone where that green little cap fit in there. And same here, I probably should have stopped there. But if I tap this enough, I bet this rice is gonna settle in nice and smooth across the top there. 1/3 of this. The cone's volume is 1/3 of its cylinder that matches. So, with that said, we can now get the volume of this cone. 1/3 pi, the radius is 4 squared, times the height, not the slant height, but the height is 9. 16, oh, by the way, 1/3 of 9 is 3. So I have pi times 16 times 3. And 16 times 3, I think is 64. Nope, it's 48. 48 pi millimeters cubed. We're talking about volume. And if I multiply that by pi, I get 150.80. All right, last figure. The sphere. Surface area is 4 pi r squared, and the volume is 4/3 pi r cubed. It's kind of interesting because if you remember, pi r squared is the area of a circle. So it's like if you took that radius and you took 4 circles and kind of wrapped it on this ball, you would have the same amount of area. 4 circles is the surface area. It's kind of wild, it's true. The radius is 22 inches. I've got to square that and multiply it by 4. 4 times 22 squared. Hablam! 1936. That was a good year. And if I want to know what that is as a decimal, I just need to multiply by pi, and I get 6,082.12 square inches. Volume, 4/3 pi, it's the radius cubed now. I hope that makes sense. Area has squared, volume has cubed. I hope that makes sense. Get out the old calculator like I did before. I'm going to go 4 divided by 3 times 22 cubed. And I get this wacky number. 14197 1/3 pi inches cubed. And if I multiply that by pi, I get 44,602.24 inches cubed. All right, so this note sheet is now complete. You've got all of your formulas. Forgot to put these in boxes. You've got every formula here. You've got examples. You even see a little bit of the kind of curveballs they'll throw you, like we saw here. We even brought out old formulas. You've got a lot of good stuff here. Please, I hope you're able to print it off or come to school and get your own copy, but fill yours out.